Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading and helping you out. I'm doing the 29th question. Uh, Please note that you must expect a total number of 33 questions, guys. Né? Organic is a huge chapter, so please bear with me. The flow diagram below shows how prop 1 in can be used to prepare to prepare other organic compounds. Okay, from prop 1 in, reaction A, we are moving from prop 1 in to forming a propane. Ne? That means for us to do that, we must add a hydrogen gas. Are you together? And this type of reaction is addition reaction. Ne? That's addition reaction. And the type of addition reaction is called hydrogenation. Okay, so the reaction condition needed, you'll only need a platinum. Okay, and then for us to form a compound X, moving from a prop 1 in, ne, we must add our hydrogen halide to form a major product. Are you together? And the major product, guys, remember that our prop 1 in was like this, ne? Our prop 1 in was like this. Whenever we add this guy over here, we'll obviously separate this bond to create other bonds there. Are you together? So whenever we do that, Markov-Coase rule simply tells us that whenever we are dealing with addition reaction, hydrogen will be attracted to the carbon that has the highest number of hydrogens. Ne? If you compare this carbon there and that one, which one has more hydrogens? The one at the terminal carbon has more hydrogens. So this will be H and that will be Br over there. That will be our major product. Né? So for us to form our major products, this was addition reaction. And then whenever I want to reverse from compound X into prop 1 in, that means we must eliminate these two. Are we together? So reaction D is just elimination. And the type of elimination is dehydrohalogenation. Okay, and then if you want to move from a propene to an alcohol, are you together? Our alcohol, remember that guys, the major product, the prop 1 in was like this, right? With hydrogens all around. For us to form alcohol, guys, we need excess amount of water. Are you together? So whenever we add that excess amount of water, this over here will separate and then will create bonds there. Ne? So our major products of our alcohol, same thing applies, guys. The hydrogen will be bonded to the carbon with the highest number of hydrogens, and then the OH will be here. Are you together? So reaction C, it's addition reaction. The type of addition would be hydration. Are you together? But now whenever I want to move from alcohol going back to prop 1 in, that means I must just eliminate these two. So reaction B is just elimination. Okay, if I want to move from reaction X to reaction, if rather I want to move from compound X to the alcohol, this type of a reaction from here to there, this type of a reaction is called a hydrolysis. Are you together? It should be in the presence of sodium hydroxide, which is concentrated, as well as mild heat. Are you together? The type of reaction is substitution. but it has a specific name which is called hydrolysis. Are we together? But I can also move from here to there. Are we together? It's just a substitution reaction. That's how, guys, you should analyze before you even start to answer the questions. Just analyze like that, né? Okay, now let's answer, guys. But yeah, we must write down the type of reaction represented by A, né? Where is A? A, we are moving from propene to propane. Are you together? The type of reaction represented there, it's addition. And the type of addition reaction, that's hydrogenation, because we need to add hydrogen to move from propene to propane. The new reaction D, that's elimination. That's elimination, yeah? And the type of elimination reaction, it would have been dehydrohalogenation. And then for reaction F, we are just substituting, we are just moving from alcohol to a haloalkane. This is just a substitution reaction, and the condition that would be needed would have been heat, né? It's just substitution. It's just substitution reaction. Okay, and then now we must write down the name or formula of the catalyst needed for reaction A. I've already written the name of the catalyst, guys, né? Whenever you deal with hydrogenation, the catalyst that you will need is platinum. Okay, 4.2.2, write down the name or formula of the inorganic reagent needed for reaction B. Where's reaction B? We are moving from an alcohol to propene, né? That simply means that we are eliminating. Remember that, guys, reaction B is elimination. We are eliminating water. Are you together, guys? We are eliminating water. So the type of catalyst that you will need, whenever you are eliminating water, guys, the type of catalyst that you will need a concentrated strong acid. Are you together? And your acid should be sulfuric acid or phosphoric acid. Are you together? That's concentrated H2SO4 or phosphoric acid, that's H3. That's H3PO4, man. Are you together? And the type of condition that you need as well, you will need heat for that reaction to happen. Okay, the type of reaction represented by reaction C. Where is reaction C? Reaction C, we are moving from propene to an alcohol. Are you together? The type of reaction represented there is addition. That's addition reaction. And the type of addition reaction is called hydration, because you are adding water to the molecule. The IUPAC name of compound X, we've already drawn the structure of compound X. That would have been 2-bromopropane, 2-bromopropane, and then now we must use structural formula to write down a balanced equation for reaction B. Where's reaction B? Or reaction B, I'm moving from my alcohol to form a propene. My alcohol was like this. Okay, let me write it down there. My alcohol was like this. This type of reaction is dehydration, né? I will need H2SO4, and it has to be concentrated. Please remember that, guys. Ne? I will need H2SO4 as well as heat, just to eliminate these two, because the aim is to form a prop 1 in. I'll simply have in the meantime, I hope you are subscribing, Mtanenkos. Okay, plus since I'm eliminating these two, they will be added there. H2O. No, but they said they wanted structural formula, so that's H2O, oxygen bonded to 2 hydrogens. This will be the complete reaction of the structural formula. Okay, both reaction D and E take place in the presence of a strong base. What's happening with D and E? Reaction D, or it's dehydrohalogenation. Reaction E, it's hydrolysis. What's the question? State 2 conditions that will favor reaction D over reaction E. Okay, reaction D over reaction E. Remember that, guys, for reaction E, we are dealing with hydrolysis. Are you together? The only game changer here that will help us not to have hydrolysis, but elimination to form a propane, is the temperature. Are you together? If we use mild temperature, we will form hydrolysis. Are you together? But if we use high temperature heat, we will eliminate. Are you together? Just mild heat will result in hydrolysis, but a higher temperature or high amount of energy that will be needed, that will be used rather, will end up forming a prop 1 in. So the only difference here, guys, is the type of heat. Are you together? Because yes, whenever you do hydrolysis, you will need a strong base, and whenever we perform it dehydrohalogenation, we also need a strong base. Are you together? The type of heat has to be a game changer, and secondly, the state of our catalyst. Yeah, I nearly forgot that. The state of our catalyst. For hydrolysis, the catalyst must be dilute. Are you together? But for elimination, the catalyst must be concentrated. Are you together, guys? So yes, both reactions, they require similar conditions. However, if the catalyst is concentrated and we are using high temperature, we'll end up eliminating and forming prop 1 in. Are we together? But if the catalyst was dilute and we used mild heat, hydrolysis would have taken place. Thank you for your time, guys. Bye.